A very warm welcome to everyone. Thank you very much for coming and watching this video. And I am Aditya Kantasala, and during the course of this video, I will be talking about fluid structure interaction and its relevance in the real life. I will also explain what fluid structure interaction is during this video. So I am Aditya Kantasala. As I mentioned, I'm a PhD student at the Technical University of Munich, and my topic of research has also been fluid structure interaction. So as I said, I work from a PhD at Technical University of Munich and the chair of structural analysis, and my professor and Dr. Father is Professor K.U.E. Bletzinger, and mentor is Dr. Roland Wuschener. My focus has been during my PhD has been numerical analysis of couple problems, efficient algorithms, and software for coupling in co-simulation. And I promise this is I will not go more into technical details during the talk, but will explain it very generally in the following of the talk. And why I choose TUM, Technical University of Munich, as for my PhD. I can go on and on about reasons why, and here are a few of those reasons. And we have a cool Hyperloop team which has been performing and which has been on the top of the contest almost all of the time. And according to the Nature Index, TUM has 1,126 international collaborations, and it can only help during my PhD and everyone who is doing a PhD and master's and bachelor programs at Technical University of Munich. At Technical University of Munich, I'm a part of IGSE, International Graduate School of Science and Engineering, which is a 2-time winner of German Excellence Initiative and is highly transdisciplinary, by means of which IGSE brings together different disciplines and fosters projects, sponsors projects through good funding, and allows exchange of information between two disciplines, for example, biomedical engineering and mechanical engineering, and so on. IGSE during this funding also supports and encourages a lot of international collaborations. And thus encourages students for exchange of information and expertise. So at IGSE, I'm a part of project 1201, which is named Atmopace. So before I go into why this is relevant, or fluid structure interaction is relevant in real life, I will talk about what fluid structure interaction is, briefly explaining what it is. So fluid structure interaction, let's look at different words which are in the name itself: fluid, structure, and the interaction between them. As the name suggests, it is the fluid, structure, and the interaction between them. What do I mean by fluid? Fluid, as the name suggests, anything that flows. So a gas, for example, wind or air, or a liquid, for example, water, or any other liquid that we come across are fluids. On the other hand, the structure is something which is built, for example, buildings, towers, bridges, or wind turbines, and so on. Anything that is being built by humans is a structure. So what does fluid structure interaction deal with? So fluid structure interaction deals with the interaction between the fluids, for example, wind, and the structures, for example, bridges or towers or wind turbines, and so on. So how do they, fluid structure interaction in principle is how do the structures behave, or the fluid behave, when it is being acted upon by the other one. So how do the fluid behave when it is being acted upon the structure, or how do the structure behave when it is being acted upon or being pushed by the wind or the air or the water? This is what fluid structure interaction, or the study of fluid structure interaction, means. So here in the following slides, I will show you some examples on how or what fluid structure interaction is in the real life. The first example I have here is of people walking in wind. Yeah? So here, for example, as you can see, people are trying to walk in wind, and we can see that the wind is pushing the people around. It's not letting them walk around freely, it's pushing them. This is very important. I mean, this is something which we experience every day, and this is exactly what fluid structure interaction is. And we all have experienced this when walking in high wind or fast winds. Yeah. So this is what fluid structure interaction is. But as you can see, this is uncomfortable for us humans as we are walking in the wind. This is very uncomfortable. But there are also other situations where we can see such fluid structure interaction happening for us in front of our eyes. For example, a flag fluttering in the wind, or a polythene cover just flying around, or a balloon flying around in a wind. This is also a fluid structure interaction, the examples of fluid structure interaction. But as you can see, these are not so, let's say, uncomfortable, or they do not affect us a lot. They do affect us, but not so much. So we do not really care if the balloon flies around in wind, or a flag flutters in the wind. We can even say a flag fluttering in the wind is a bit pleasant to us. Yeah. But there are also instances where such a phenomena is very important, or it can cause damage to us, or it can cause damage to lives and also property. Yeah. And then cause a lot of let's say money. Yeah. In the following, I show you some examples of how this is important. Here in this example, we see a building which is a tall building which is moving in wind. Yeah. This video is from Hong Kong, and probably uh, during a storm or a cyclone. Yeah. So as we can see in this video, the building which has this white spot is moving with the wind. Yeah. So what is the effect of this? So people who are staying in this building may feel terrified. Yeah. Or may feel a bit dizzy because it's moving. Yeah. This is very inconvenient for people who are living or who are working in that video, or in that building. Sorry, in that building. Yeah. And if let's say this building keeps on moving like that, or keeps moving, if the movement keeps on increasing because of the wind, there might also be a possibility that this building collapses completely. Yeah. This is how this will affect, or such a phenomena, fluid structure interaction, will affect the design of the building. So we want the building not to move so much in this wind, or in the wind. So this is what how this is important. Fluid structure interaction is important in making such buildings, or designing such buildings. Yeah. I also have another example of a bridge here, in this case a Tacoma Bridge, which is built in 1940s in Washington State, USA. This is a classical example of why why consideration of fluid structure interaction when building such bridges is really important, as you can see. Yeah. So the Tacoma Bridge opened to general public in July of 1940, and has been in operation till before November 7th of 1940. What happened is that the engineers who built this bridge did not consider that the fluid, or the wind that can push the bridge around, and did not consider this while building the bridge, and the bridge started to react to the wind around it. Yeah. Wind forces. Yeah. The wind started to push the bridge around, and we can see that this bridge moves quite a lot during quite a lot when the wind pushes it around, and it starts moving, and as the movement increases and increases and increases, at some point the bridge actually collapses. This is what we can see in this video. The bridge actually collapses. Yeah. So in such situations, we can see this can be very dangerous for the people, or who are using this bridge. And fortunately, there are no people who lost their lives or who were injured during this incident of Tacoma Bridge. But one can imagine this can happen at any point of time during the operation of that bridge, or someone who's using that bridge, and this can be very, very dangerous. And this shows that fluid structure interaction is really important to be considered when building or designing such bridges by the engineers. Yeah. And the next example that I have is that of a wind turbine. So wind turbine, as we know, is something which can capture and generate energy or electricity during the because of the wind which is flowing around it. As we can see, this, because it's also in the wind, it can also move. As we can see, the tower moves here in the wind. Okay, now here the movement is not so much. It's not, let's say, substantial, and the tower can withstand such wind. But what if the wind is strong and the tower or the movement of the tower is high, or it's very big? Yeah. Here I have an example of that also as well. So here in this video we can see there is a strong wind that is happening around the wind turbine. Wind turbine spins and spins very fast, and at some point it fails, it collapses. As simple as that. And this is super dangerous. As you can see, there are some animals, and there are probably some people living around the wind turbine, and this is super dangerous for people who are living around, or animals who are around the wind turbine. And this exactly is what fluid structure interaction is, how the structure behaves with the flow of the fluid around it. And this is why this is important, or fluid structure study of the fluid structure interaction is important when designing such structures. Yeah. And during my PhD work, this is what exactly I do in my PhD work. I take the fluid simulations, that is the wind simulations, for example, here, and also I take the structural simulations, and I try to bring them together to simulate the fluid structure interaction problem, and give the designers a very good example, or say estimate of how the structure might behave during the fluid structure during the wind flow, for example. So here is an example of what I did together with my colleagues. This is a building which is in wind, and it is moving because of the wind flowing around it. This is an example of such a simulation. And what we try to do is we try to predict loads, or how the building behaves in such wind, and we try to give some input to the engineers so that they consider such an effect, a fluid structure interaction effect, and build better, safe, and strong buildings in the future. Buildings I talk, they are high-rise buildings. Yeah. And I also deal with simulation of wind turbines, while understanding of how a wind turbine behaves in the fluid also will enable the designers to build stronger, faster, or more efficient wind turbines, and safer wind turbines which are more resistant to failure, as we have seen before in the other video. So this is what I do during my PhD. So this is not simple. This has been very challenging, and few of the challenges that I encountered during this work is, first, how can I efficiently or accurately simulate such fluid structure interaction phenomena? This has been one prime question during my PhD. And also the next question is, how efficient or how fast can I simulate such phenomena? How can I run this simulation software or simulation tool as fast as possible on a computer, for example, on a computer, on a supercomputer, on a very big and big machine? These are the two challenges that I have tackled during my PhD work, and I will be tackling in the future also. These are, and then in conclusion, as we have seen why FSI is really important to be considered in the design of buildings, bridges, and towers, for example, as in a wind turbine. Yeah, this is why, and we have established that fluid structure interaction is important and it is necessary to consider such effect when designing such towers. This will eventually will save a lot of lives, and of course will save a lot of money also in the future. Yeah. Thank you very much for following the talk so far. And if you have any more questions, or if you have any, or if you are interested in knowing more about how we did such simulations, or what are the technical details of such simulations, please comment below in the comment section. I will be happy to come back to you and answer all your technical questions, regardless if it's technical or non-technical. Thank you very much, and I wish you a pleasant day.